Hey everyone, it's Mrs. Herbst. I'm going to cover two parts to Lesson 7.4 today. First the Explorer, and then we will do the lesson presentation. So hopefully you had some time to try to work through this Explorer on your own before you check it here and start your notes. Step 1 asked you to use the grid at the right to draw a square that has an area of 16 units, and then to write what the length of one side of the square is. So what we know about a square is that all four sides are equal. So as you're practicing drawing or trying to draw a square with an area of 16 units, hopefully you found that a square that had side lengths of 4 would give you an area of 16 because 4 times 4 is 16. In step 2, you're asked to draw a square with an area of 49 units squared and then state the length of that square's side. So hopefully you found or drew a 7 by 7. If you were to count those squares inside the square, the area, you would count 49 squares. So again, the side length here would be 7. 7 times 7 is 49. In step 3, you were then asked to draw a square that had an area of 12 units squared. So this became more difficult because we know that a 3 by 3 would give us an area of 9, and a 4 by 4 gives us an area of 16. So I actually tried to draw a square that would have a side length of 3.5. And when you calculate the area of that square, you get 12.25. So it's pretty close. So step A asked to approximate the length of one side of that square. So I said about 3.5. It would actually have to be a little bit less than that, since 3.5 times 3.5 was 12.25. That was a little bigger than 12. Then step B asks you to, after these investigations, to see if you can define what a perfect square is and state maybe why 16 and 49 are perfect squares, but 12 is not. So perfect squares are the product of an integer and itself. We saw in steps 1 and 2, 4 times 4 is 16 and 7 times 7 was 49. But we struggled here because we couldn't quite exactly get to 12 with an area. If I knock it back down to, let's say, like 3 1/4, then we don't quite get to 12. It's 11 point something in terms of the area there. Step 4, I know on the document I pulled up electronically here has step 4 way at the bottom of this page. Hopefully it's at the top of the back side of yours, but you're asked to complete this following table all the way through a side length of 12. So we see that if we have side lengths of squares in this first column, then we can calculate the area of that square by squaring the side length. And then what we see in the far column is the list of perfect squares. So as you move down that middle number, you're just writing the side length of the square to the second power. So you can see that all the way through 12 squared. And then in the far column, you're just multiplying each of those integers times themselves. 3 times 3 is 9, 4 times 4 is 16, and so on, all the way down to 12 times 12 is 144. Now hopefully you're pretty good with your multiplication facts. You should have probably known all of these already. So now if we want to look at this table and we want to determine what is the side length if we know the area. So for letter A, it was 100 square units. So we can see that here. So a square will have a side length of 10 units if its area is 100 square units. For letter B from your table, you can see that 64 square units comes from a square with a side length of 8 units, and a 25 square unit square would have a side length of 5 units. We are skipping step 6. We don't work with cubes or perfect cubes in 7th grade. So let's head over to the PowerPoint. You should have a note sheet. If you can pause the video for a moment so that you can write your goal at the top of the note sheet, and then we'll move on. So first, some vocabulary terms. Your vocab should be taped at the beginning of this unit in your math notebook. So a perfect square is a number whose square root is an integer. Remember, integers are positive and negative whole numbers. When you calculate or find the square root, it is going to be one of the two equal factors of a number. So we have this infographic on your note sheet, and again, finding perfect squares literally comes from the concept of area of squares. So you can see that a 2 by 2 square would have an area of 4 because 2 times 2 is 4. 3 times 3 is 9, so a side length of 3 gives that square's area 9. And then you can see 6 by 6 is 36. On your notes, you do have this table also to fill in, so you can pause the video here as you complete this table. And when you're ready to move on, you can hit play. Also, just so we're all using proper mathematical vocabulary, when you see the square root of a number, that's how it's read. So in that green box, you can see that it's read the square root of 25. So in the first example, we're just finding the value of each square root. So you're going to ask yourself, what number times itself is 9? So the answer is 3, because 3 times 3 is 9. In letter B, the square root of 121 is 11, and that's because 11 times 11 is 121. So go ahead and pause the video here as you find this value of each square root in extra example 1. For letter A, the square root of 25 is 5, and for letter B, the square root of 1 is 1. A few more vocabulary terms, so if you could flip back to your vocab. A rational number is a number that can be expressed as a fraction of two integers. So all integers are rational numbers because we can write them over 1. For example, 8 over 1. 8 is an integer, and we can write it as a fraction. Also, all the common fractions, you know, a half, 3/4, 9/10, right? All of these fractions are written as a ratio of two integers. And even decimals, right? There are a lot of common decimals that you know what they are in fraction form, but know that many decimals can be written as fractions. So here are some more examples again. 3 because it's 3 over 1, and my example above of 0.25 because it's 1/4. Some of you know that some repeating decimals can also be written as fractions. The two most common repeating decimals you probably know are 0.3 repeating, which is 1/3, and here it shows 0.6 repeating, which is 2/3. Also mixed numbers, we can write mixed numbers as improper fractions, and so then those are all examples of rational numbers. So what's an irrational number? This is a number that cannot be expressed as a fraction of two integers. The most common irrational number that you do actually know is pi. Remember that pi is equivalent to 3.1415, and that goes on forever, and it doesn't repeat. So there's some key pieces to being irrational. It means that they are decimals that don't end and never repeat. And so that's the good to know part. Okay, so now that we know what perfect squares are, we're going to look at some non-perfect squares and just do a little bit of estimating. And you can use the chart that's in your notes to help you. So when we're asked in letter A to calculate or find the square root of 35, you might recognize pretty quickly that 35 is not a perfect square. 6 times 6 is 36, so it's close, but 5 times 5 is 25. So the number 35 is not a perfect square. It kind of gets skipped over. So in this set of directions, you're asked to determine which two positive integers each root does lie between. So if we just kind of look at a number line, and again, we stated a moment ago that the square root of 36 was 6, and that the square root of 25 is 5. So you can see how the square root of 36, because square roots actually are also just go in numerical order, the square root of 35 would be somewhere down here. So for this example, because 35 falls between the two perfect squares 25 and 36, then the square root of 35 falls between 5 and 6. Letter B is asking for the square root of 83. So if you're thinking about the perfect squares that lie on either side of 83, hopefully you're thinking the square root of 81, which is 9, and the square root of 100, which is 10. Square root of 83 would be a little closer to the square root of 81 than it would be to the square root of 100, but the two positive integers here that the square root of 83 falls between are 9 and 10. When you answer questions like this, you will always give two consecutive numbers. You'll never skip and say something like, oh, it's between 5 and 8. Nope, they have to be consecutive numbers, so 5 and 6, 9 and 10. And I'm going to kind of skip through this typing from the math program. Okay, extra example 2 asks you to determine the two positive integers that each square root falls between. So you can go ahead and pause the video here while you work through these two examples, and then you can hit resume to check your answer. So the square root of 7 falls between 2 and 3 because 2 times 2 is 4 and 3 times 3 is 9. Letter B, the square root of 75 falls between 89. 8 times 8 is 64 and 9 times 9 is 81. So 75 falls between 64 and 81. So that's the end of the video. You can go ahead and tape this into your math notebooks. And it's time to now move on to the next part of the lesson.